Dear students, in the last class so far, we discussed symmetric matrix and skew symmetric matrix definitions along with some standard examples. What do you mean by symmetric matrix? A matrix is said to be symmetric if A dash is equal to A. What is A dash? A dash is nothing but a transpose of a matrix. And what is a skew symmetric matrix? A dash is equal to minus. If a matrix satisfies A dash equal to A condition, then it is called a symmetric matrix. If a matrix condition satisfies A dash is equal to minus A, such matrix we call as a skew symmetric matrix. Just remember that one. If you want to write an example of a symmetric matrix, what you have to write? Whatever the diagonal elements, you have to write the position A1, 1 to A2, 1. Both are same. Aij to Aj. If you want to write a skew symmetric matrix, what you have to write? You must write the principal diagonal elements must be 0. Diagonal elements must be 0. And here you can write any element. But 2 is there means there must be 2, minus 2. If it is 4, 3 means minus 3, 4 means minus 4. Write the opposite sign. If it is minus 4, you have to write plus 4 here. Okay? Like this examples we discussed in the previous class. Okay? Now, I said in the last point that for any square matrix A, A plus A dash is always symmetric. A minus A dash is always skew symmetric. I said, but not proved. I have not proved that point. Today we will prove that theorem. We can make it as a theorem. Theorem statement is like this. Theorem statement is like this. For any square matrix, I am mentioning very clearly square matrix. For any square matrix A, A plus A dash is symmetric matrix. A plus A dash is a symmetric matrix and A minus A dash is skew symmetric matrix. A minus A dash is skew symmetric matrix. A plus A dash is a symmetric, A minus A dash is always a skew symmetric matrix. We will prove this theorem. Just you can ask. What is the symmetric definition? I said very clearly. What is symmetric definition? Symmetric definition is what? Symmetric matrix definition A dash equal to A. What about skew symmetric? Skew symmetric definition A dash equal to minus A. This is the skew symmetric definition. This is the symmetric definition. Now come to the point. We have to prove A plus A dash is symmetric. Just look at this. I will take P equal to A plus A dash. P is what? One matrix which is A plus A dash, which is represented by A plus A dash. Let us I have taken. I have to prove A plus A dash is symmetric. A plus A dash is symmetric. I want to prove that means P is symmetric. I want to prove that P is symmetric. That's why I have to prove what at the end. P dash is equal to P. I have to show this. P dash is equal to P. If I show this, the proof is over, isn't it? P dash equal to P means what? P is symmetric. P is nothing but A plus A dash. Okay? Are you getting? I think. Now, we have to simplify. Just I will make it. P is A plus A dash. Therefore, P dash equal to what? P dash equal to what? A plus A dash whole dash. Isn't it? Because P is A plus A dash, P dash is A plus A dash whole dash. Now what happened? According to the properties of a transpose of a matrix, A plus B whole dash. Just remember, A plus B whole dash is equal to what? A dash plus B dash. I said the property. So apply here. A dash plus, this is a B dash. B is nothing but A dash. Isn't it? Now what happened? A dash plus A dash whole dash is what? I also say that property. A dash whole dash is what? A dash whole dash is A. Therefore, this is A dash plus A. A dash plus A is nothing but what? A plus A dash. Commutative holds. Commutative holds under matrix addition. 2 plus 3 equal to 3 plus 2. Same thing. A dash plus A equal to A plus A dash. What is A plus A dash? It is nothing but a P. So P dash is equal to A plus A dash. P dash is nothing but a what? It is nothing but a P. Therefore what? A plus A dash is symmetric. What I have written earlier, I have to prove this. P dash equal to P. That means P dash equal to A plus A dash. A plus A dash is nothing but a P. This is a proof of A plus A dash is symmetric. Let's just look at this. Next, we have to move for second part of the proof. Second part is what? A minus A dash is skew symmetric. Let us I will take Q equal to one matrix. Q is what? A minus A dash. I want to show that A minus A dash is a skew symmetric. What I have to do? I have to prove at the end what I have to show? Q dash equal to minus Q. Q dash equal to minus Q in the sense what? According to the definition, Q is what? Skew symmetric. According to the definition, Q is skew symmetric. Right? So make it use of that property. Now we have to prove this. No. Let us look at this. Q dash is equal to A minus A dash whole dash, isn't it? Now, according to the property, A minus B whole dash is equal to what? A dash minus B dash. Just we have to make use of that. A minus B whole dash is what? A dash minus A dash whole dash. A dash minus A dash whole dash. Now come to the point. A dash as it is. A dash whole dash is what? A dash whole dash is what? A dash whole dash is what? A. So A dash minus A minus A, total different, I will take it minus common. If I take common minus, what happened? It will be interchanging. A minus A dash. A minus A dash. What is A minus A dash? A minus A dash is nothing but a Q. So left side Q dash. Q dash equal to minus it is there. It is nothing but a Q. Therefore what? Q dash equal to minus Q means what? I said Q is skew symmetric. Q means what? A minus A dash is skew symmetric matrix. Q is a skew symmetric matrix. So there might be a chance of this question. Prove that if A is any square matrix, A plus A dash is a symmetric matrix. Or he may ask the question, for any square matrix A, prove that A minus A dash is a skew symmetric matrix. If they ask A minus A dash skew symmetric, you have to do like this. If they ask that A is a skew symmetric matrix, like this, you have to prove. Okay. Now we will move on next theorem. Next theorem. The similar proof. It is depending upon this theorem only. I will make use of that. Statement of the next theorem is very important. The statement, what I will write now, is very important, that we have to make use of that. Next theorem, I can make it. Any square matrix can be expressed as sum of symmetric matrix and skew symmetric matrix. Look at this. Any square matrix can be expressed as a sum of symmetric and skew symmetric matrix for any square matrix. Let us look at this. Just proof. The statement of this is very important for solving questions related to 3 marks question. Let us look at that. For any square matrix, the previous theorem makes a very important rule here. That previous theorem, for any square matrix A, we can write A is a square matrix. I can write it as a 1 by 2 A plus A dash plus 1 by 2 A minus A dash. How I have written? We will see that one. Just observe. Multiply half here. Multiply half means just simply roughly. I am not proving it. Just how I have written. I will explain. Multiply here. This is A by 2. This is A dash by 2 plus half multiply A by 2 plus minus plus into minus A dash by 2. A dash by 2 A dash by 2 gets cancelled. A by 2 A by 2. It becomes what? It is nothing but a A. That's why I have written. For any square matrix A can be expressed like this. And observe. Just now I proved in the previous theorem. In the previous theorem I proved that. What is that statement? What is that statement? A plus A dash is always a symmetric. A minus A dash is always a skew symmetric. So observe, this is what always a symmetric. This is what skew symmetric. Multiply by 1 by 2. It is a scalar quantity. Suppose if I take one matrix, observe 2, 4, 4, 0. Is it a scalar matrix? Sorry, it is a symmetric matrix. Multiply here. 1 by 2A. What happened? 1 by 2A. 1 by 2 multiply. What happened? 1 by 2 into 2, 1, 2, 2, 0. Is it again a symmetric matrix? Yes. That's why I said this is symmetric. This is skew symmetric. What happened? The sum of symmetric and skew symmetric. This is the statement. Sum of symmetric and skew symmetric. This is symmetric, this is skew symmetric. Sum of symmetric matrix and skew symmetric matrix can be expressed as a for any square matrix we can express as a sum of symmetric and skew symmetric matrix. This is very important. You can remember this 1 by 2 A plus A dash plus 1 by 2 A minus A dash. This statement is required to remember that point. It's very important. Okay. Proof is very simple. And now we will move on problems related to symmetric and skew symmetric matrix. Related to this, there will be 3 marks question. Chances will be there for annual examination. We will discuss now. Okay. Examples. Express a matrix A equal to 2, 1, 3, 5 as sum of symmetric and skew symmetric matrix. Sum of symmetric and skew symmetric matrix. Look at this question. Okay, we have to express this matrix as a sum of symmetric and skew symmetric matrix. Like in previous example, previous theorem, I states A is equal to, we know the property. We have A is equal to 1 by 2 A plus A dash plus 1 by 2 A minus A dash. We know the property. Okay. Let us look at this. Now let us take this part and this part separately. Okay. Now let us, I will take P matrix. This I will take P. This I will take Q. Okay. Let us take 1 by 2 A plus A dash. So 1 by 2 as it is. Just observe the point. What I will write. A matrix keep as it is. A matrix 1, 2, 1, 3, 5. Plus A dash is what? 2, 1, 3, 5. Interchanging the rows and columns. 1 by 2 keep as it is. Adding the matrices. 2 plus 2, 4. 1 plus 3, 4. 3 plus 1, 4. 5 plus 5, 10. Right? Now 1 by 2 multiply. 1 by 2 multiply means 1 by 2 into 4, 2. 2, 5. Let us take this one. Just observe. This is the P matrix. P dash is equal to, what happened? P dash, just remove one. P dash, make it transpose. 2, 2, 2, 5. What happened? This is nothing but a P. Therefore, P is what? P is what? Symmetric. What is P? What is P? This is the P. Okay? Next, let us take Q. I will take, this is a Q. I will take Q means A minus A dash. Okay? 1 by 2. Observe the point. A is what? A is what? 2, 1, 3, 5. Minus. Next. 2, 1, 3, 5. A dash. A minus A dash. 1 by 2, keep as it is. Subtract. 2 minus 2, 0. 1 minus 3, minus 2. 3 minus 1, 2. 5 minus 5, 0. 1 by 2 multiply. What happened? 0, minus 1, 1, 0. Okay? This is what? Q. Q dash is equal to what? Q dash is what? 0, minus 1, 1, 0. 0, minus 1, 1, 0 like this. Take a minus common. Minus common means what happens? 0, minus 1, 1, 0. So this is what? Same as a Q. So this is minus Q. Q dash becomes what? Minus Q. Q dash becomes minus Q. Therefore, Q is what? Skew symmetry. Observe the point. P is what? P is what? Symmetric. Q is what? Skew symmetric. P plus Q is what? A. P plus Q is what? A. Okay? P plus Q is what? Or you can observe. P plus Q. Make use of that. What is P? Where it is? Where it is P? This is P. Right? P. You can write it here. 2, 2, 2, 5. Plus Q is what? Q is where it is? Where it is? Q. Q. This is a Q. Okay? 0 minus 1, 1 0. Add this. What happened? 2 plus 0, 2. 2 minus 1, 1. 2 plus 1, 3. 5 plus 0. This is nothing but a 2, 1, 3, 5. P plus Q is equal to what? A. A square matrix can be expressed sum of symmetric and skew symmetric. This is observed symmetric. This is observed skew symmetric. Therefore, hence the proof. This is for 3 marks. Usually, if you practice more, you will get that. You will solve some problems. Stop. Okay, we will continue next question. Express the matrix A equal to, take any square matrix. Don't worry about that. Take any square matrix. 2 minus 1, 6, 4. If I take like this. Okay, take any square matrix as sum of symmetric and skew symmetric matrices. Skew symmetric matrix. Similar question I will take because this is the most important question for 3 marks. Easiest way to get 3 marks solution. Just look at this. We have A equal to what? Statement I said. You have to write A plus 1 by 2, A plus A dash plus 1 by 2, A minus A dash. Okay? Let us take this is a P part, this is a Q part. Okay? Let us take a P. P equal to 1 by 2, A plus A dash, 1 by 2. A is what? A is a matrix 2 minus 1, 6, 4. Plus A dash is what? 2 minus 1, 6, 4 like this. Making a transpose. Next 1 by 2 capacities. 2 plus 2, 4. Minus 1 plus 6, 5. 6 plus minus 1. 6 minus 1, 5. 4 plus 4, 8. Making a multiply by 1 by 2. It becomes 2. It becomes 5 by 2. It becomes 5 by 2. It becomes 4. This is what P. Okay, now what happened? P dash becomes what? P dash. 2. Row becomes column. Column becomes row. 5 by 2, 4. Is it nothing but again P matrix? Therefore, P is what? Conclusion. P is what? Symmetric. Next, let us take Q. Q is what? Half of the next half portion. 1 by 2 A minus A dash. 1 by 2 A is matrix 1. 2 minus 1, 6, 4 minus A dash. A dash becomes 2 minus 1, 6, 4. Make interchanging rows and columns. Now what happened? 1 by 2 keep as it is. Subtraction. 2 minus 2, 0. Minus 1 minus 6 minus 7. 6 minus minus plus 1. 6 plus 1, 7. 4 minus 4, 0. Okay? 1 by 2 multiplied. 1 by 2 into 0, 0. 1 by 2 into minus 7. Minus 7 by 2. Plus 7 by 2, 0. Right? Taking this is a Q. Okay? Q dash. Q dash is what? 0 minus 7 by 2. 7 by 2, 0. Taking minus common. What happened? If you take minus common, 0 minus 7 by 2. 7 by 2, 0. Minus Q. Q dash becomes minus Q. This is what Q, isn't it? Observe. So that's it. Minus minus. Q dash equal to minus Q means what is your conclusion? Q is what? Skew symmetric matrix. Q is what? Skew symmetric matrix. Isn't it? Now P plus Q. P is a symmetric. Q is a skew symmetric. What about P plus Q? Just look at this. This is a P, I think. Same. No problem. 2. 5 by 2, 5 by 2, 4 plus Q. Q is where it is. Q is here. 0 minus 7 by 2, 7 by 2, 0. Adding the elements. 2 plus 0. 2 plus 0, 2. 5 by 2 minus 7 by 2. Just calculate. 5 by 2 minus 7 by 2. Observe. LCM is what? LCM is what? 2. 5 minus 7. Minus 2. Minus 2 by 2. Minus 2. You can write it very fast. Minus 1. 5 by 2 plus 7 by 2. 5 by 2 plus 7 by 2 becomes what? LCM 2. 5 plus 7. 12. 12 by 2. 6. 4 plus 0. 4. Okay. This is nothing but again A. So sum of symmetric and skew symmetric matrix is A. This is ideal. If you practice one more example of order 2, you will get the clear idea. Okay. I will not take that 2 cross 2, I will take 3 cross 3 matrix. I will make use of 3 cross 3 matrix. Take any square matrix. 2, 4, minus 6, 4, 0, minus 8, 3, 1, 5. This is any square matrix. You can make use of any square matrix. I will solve it, but I will write as little bit small numbers because board is not sufficient to solve one problem in one board. Just we can observe. I will cover the points. Just observe. Same way, order 3 is there. Order 3, we have to write it. Order 3. Okay. Let us take P. P is equal to what? 1 by 2 A plus A dash. 1 by 2. A matrix is what? A matrix 2, 4, minus 6, 4, 0, minus 8, 3, 1, 5. Minus. This is a dash, sorry, plus it is A plus A dash. A dash 2, 4, minus 6, 4, 0, minus 8, 3, 1, 5. This is A plus A dash. 1 by 2, A plus A dash. Make use of same property. 2 plus 2, 4. 4 plus 4, 8. Minus 6 plus 3, minus 3. 4 plus 4, 8. 0 plus 0, 0. Minus 8 plus 1, minus 7. 3 minus 6, minus 3. 1 minus 8, minus 7. 5 plus 5, 10. Be careful. If we did mistake also let you will get it. 1 by 2 into 2. Oh, 4. 1 by 2 into 4, it becomes 2. It had happened here 4. Minus 3 by 2. 4, 0, minus 7 by 2, minus 3 by 2, minus 7 by 2, 10 by 2 is 5. Just you can rewrite. Observe the point. And what about the point here? The same matrix. This is a observe the point. If you leave these diagonal elements, what happens? This is exactly what? Symmetric matrix. I can write this is a P. P dash is equal to what? P dash is equal to what? Making interchanging rows and columns. Interchanging rows and columns. 2, 4, minus 3 by 2. This is the 4, 0, minus 7 by 2. Minus 3 by 2. Minus 7 by 2. 5. Observe, this is same matrix. We got the same as we got it. P dash equal to P. Therefore, P is what? Symmetric matrix. P is what? Symmetric matrix. Similarly, let us take next half. Q part. 1 by 2. 1 by 2. And how to write it? 1 by 2. A minus A dash. A minus A dash. 1 by 2. What is A matrix? Keep the point at it. 2, 4, minus 6, 4, 0, minus 8, 3, 1, 5. I have to write very small numbers because the board is not sufficient. I hope you will get the clear idea. Plus, minus A minus A dash. A dash means transpose. 2, 4, minus 6, 4, 0, minus 8, 3, 1, 5. Okay? 1 by 2. Subtract 2 minus 2 0, 4 minus 4 0, minus 6 minus 3 minus 9, 4 minus 4 0, 0 minus 0 0, minus 8 minus 1 minus 9, 3 minus plus 6 9, 1 minus plus 8 9, 5 minus 5 0. Okay, 1 by 2 multiplied. 1 by 2 multiplied. 0 0 minus 9 by 2, 0 0 minus 9 by 2, 9 by 2, 9 by 2, 0. Okay, this is a Q. What about Q dash? Q dash becomes what? I will write here better. Q dash becomes what? Q dash 0 0 minus 9 by 2. Next 0 0 minus 9 by 2, 9 by 2, 9 by 2, 0. Okay, taking minus common. What happened? Minus common take means 0 0 minus 9 by 2, 0 0 minus 9 by 2, 9 by 2, 9 by 2, 0. Okay, so this is nothing but a what? This is nothing but a Q. Observe the point. This is a Q. Q dash is equal to minus Q. Conclusion is what? Q is what? Skew symmetric matrix. Skew symmetric matrix. Therefore, now what happened? P plus Q is equal to what? P is what? Where it is P? This is the P or this is P? You can take. No problem. P is what? 2 4 minus 3 by 2, 4 0 minus 7 by 2, minus 7 by 2, minus 3 by 2 I think it is, minus 3 by 2, minus 7 by 2, 5. Plus Q. Q is what? This is the Q. This is where it is 0. 0 0 minus 9 by 2, 0 0 minus 9 by 2, 9 by 2, 9 by 2, 0. I hope you are getting P plus Q. How to add? I will write directly. 2 plus 0, 2. 4 plus 0, 4. Minus 3 by 2, minus 9 by 2. Minus 3 by 2, minus 9 by 2. What happened? Minus 3 minus 9 becomes what? Minus 12. Minus 12 by 2, minus 6. 4 plus 0, 4. 0 plus 0, 0. Minus 7, minus 9. Minus 7 by 2, plus, minus 9 by 2. Minus 7, minus 9 becomes minus 16. 16 by 2, minus 8. Minus 3, minus 9. Plus 9. Minus 3 plus 9 becomes what? 6. 6 by 2, 3. Minus 7 plus 9. Minus 7 plus 9 means 2. 2 by 2, 1. 5 plus 0, 5. This is the we got A matrix. Same. 2, 4, minus 6, 4, 0, minus 8, 3, 1, 5. Okay. So we got the same answer as in A. This is the symmetric matrix part. This is the skew symmetric matrix part. P plus Q. Symmetric plus this is symmetric. This is skew symmetric. Sum of symmetric and skew symmetric matrix as a we express it as a given square matrix. Okay. You can make use of any examples regarding that. Take many examples. Take your own examples. You can make it practice. Okay. I will give some examples, or you can make it practice yourself only. Express a matrix. Write any number. Write choice your own numbers. Whatever 2, 1, 0, minus 1, 2, 4, 6, 5, 3. Any number. You can write it any number. Of order 3 it is there. Order 2 also you can take. Order 2 also you can take. Any examples, you will get the clear idea. If you got the same matrix, you did it correctly. If you got a little bit of silly mistake happen, means you did something wrong. So this is the idea to get the symmetric and skew symmetric matrices idea. Okay, we will continue in the next class. Main part invertible matrices and very important for 3 marks. If they ask that question, they won't ask this. So any one will be there. We will discuss it in that next class. Okay, thank you.